Hello everyone, I am Vishnuvardhan. So thank you for joining. So good morning everyone. Thank you all for joining the session on Azure AI Fundamentals. And as you know, I am Vishnuvardhan and I am excited to be your guide as we explore how Azure AI can transform the way businesses and developers build intelligent solutions. So let me share my screen. Wait a minute guys. I hope my screen is visible now. Yeah, thank you for the confirmation. So today, artificial intelligence is more than just a buzzword. It's a really that's rapidly changing industries, enhancing productivity, and proving new insights. But for many, integrating AI into their applications can seem daunting and complex. So there's where Azure AI comes in. Microsoft has created a suite of AI services that allow everyone from developers to business leaders to easily integrate AI into their projects without needing deep expertise in AI or data science. This session aims to give you a gentle introduction to these services, helping you understand what's available and how can you leverage them. So, here's how we will spend the next hour together. We will start with an overview of Azure AI and its key components. Then, we will dive deep into Azure Cognitive Services, which provide pre-built APIs for vision, speech, language, and decision-making tasks. We will also explore Azure OpenAI services and see how advanced language models like GPT-4 can be used in real-world scenarios. Finally, we will discuss responsible AI use, a critical aspect of developing AI solutions. My goal for this session is to give you a foundational understanding of Azure AI, its capabilities, and some practical use cases. Whether you are a developer looking to enhance your applications or a business leader exploring AI opportunities, there's something here for everyone. I encourage you to note down any questions or ideas that come up during the presentation. We will have a Q&A section at the end. I would love to hear your thoughts and answer any queries. So let's get started and delve into the world of Azure AI. In the next slide, we will explore that what is Azure AI is and how it's structured to help you bring AI into your applications effortlessly. So now that we have a high level overview of what we will cover today, let's dive into the heart of our discussion, Azure AI. Before we get into the species, let's understand what Azure AI is all about. So Azure AI is a collection of cloud-based artificial intelligence services provided by Microsoft. These services are designed to help developers, data scientists, and businesses easily integrate AI into their applications. The key advantage here is that you don't need to be an AI expert to leverage these powerful tools. So think back to November 2021. So these are all the Azure AI services you can see in the slide. So Azure AI is broadly categorized into four main components. The first one is machine learning platform, cognitive services, application applied AI services, and Azure AI applications and tools. So you can see here. So coming to the machine learning platform, this is for building, training, and deploying machine learning models. It's a comprehensive platform for data scientists and developers who want full control over their models. These are pre-built APIs that offer ready-made solutions for uh, common AI tasks like image analysis, speech recognition, and language understanding of cognitive services. Coming to the applied AI services, these are tailored scenario-based services for specific use cases like personalized recommendations or business process automation. And coming to the Azure AI applications and tools, these include AI Builder, Power BI, and Power Apps, which enable business users to create AI driven solutions with little no to coding. So, to provide you a practical example, imagine you are building an e commerce website and you want to enhance the user experience. You can use Azure Cognitive Services to add a chatbot for customer support, integrate a recommended engine to suggest products, and even use image recognition to enable customers to search by uploading pictures of products they want to find. All of this can be done without having to build complex models from scratch. So the beauty of AI, Azure AI, is that it's designed for everyone. Developers who want to build intelligent applications, data scientists who need a robust platform for experimentation, and even business users who can create AI driven solutions using low code or no code tools like Power Apps. It democrates AI, making it accessible to all. And because Azure AI is part of the Microsoft Azure cloud platform, it comes with all the benefits you would expect, such as scalability, security, and compliance. You can scale your AI models as your business grows and ensure that your data is protected with enterprise grade security measures. In short, Azure AI provides a comprehensive suite of tools and services that cater to different levels of AI expertise and business needs, making it easier than ever to bring the power of AI to your applications and processes. Now that we have covered the basics of Azure AI, let's move on to explore one of its popular component, Azure Cognitive Services, which build pre-built models for a variety of AI tasks. These services can save you time and effort, allowing you to focus on building different applications without worrying about the underlying AI technology. So what is all the hype about? And you can see the rising speed of technology adoption. You can observe the graph here. uh, these are the tools like for podcasting, tablet, social media usage, smartphone usage, microcomputer, computer, internet, cellular phone, microwave, power steering. In the present recent generations, these were hugely very increasing and on demand skills. Now that we have got a high level understanding of Azure AI, let's take a closer look at one of its most versatile and accessible components, Azure Cognitive Services. These services provide a range of pre-built AI capabilities that can easily integrate into your applications. Azure Cognitive Services are a collection of APIs, SDKs, and services that make it simple to add intelligent features to your applications. They cover a wide range of AI tasks, from understanding natural language and recognizing speech to analyzing images and videos. The best part, you don't need to have advanced AI or machine learning skills to use them. These services are grouped into four main categories, each addressing different aspects of AI. The first one is vision, speech, language, and decision. To illustrate how these services can be used, let's consider a retail business by integrating vision services. The business can implement a product recommendation system based on visual similarity. If a customer uploads a photo of an item they like, the system can suggest similar products available in the store. Meanwhile, long-range services can be used to power chatbots that handle customer inquiries, while speech services can enable voice search and visual assistance in the store. By leveraging Azure Cognitive Services, by leveraging Azure Cognitive Services, you can significantly reduce development cost and time. You don't have to build complex AI models from scratch. Instead, you can use three pre-built solutions to quickly add advanced capabilities to your applications. Now that we have a good grasp of what Azure Cognitive Services can do, let's shift our focus to another exciting part of Azure AI, OpenAI service. This service allows you to create advanced language models like GPT-3 and GPT-4 to create even more sophisticated AI applications. So that we have explored the capabilities of Azure Cognitive Services, let's move on to the one of the most exciting and transformative offerings within the Azure AI suite, Azure AI Open Services. This service brings the power of advanced models like GPT-3, GPT-4 directly to your applications. Azure OpenAI Services provides access to some of the world's most powerful language models, enabling you to perform tasks like text generation, content creation, language translation, and even writing code. These models are built using a deep learning architecture known as transformers, which allows them to understand and generating human-like text. What make these models truly revolutionize is their ability to understand context and generate coherent, meaningful responses to a wide variety of prompts. For example, you can ask the model to summarize a complex document, generate creative content like stories or articles, or even write code snippets based on the description of what you want to achieve. Let's take a look uh, at a few practical applications of Azure OpenAI services. So the first one is content generation. Imagine you are running a market campaign. You can use GPT-4 to generate engaging blog posts, social media content, or product descriptions in seconds. freezing up your team to focus on strategy rather than writing. Next one is customer support automation. You can build intelligent chatbots that not only respond to customers' inquiries but also understand the context of the conversation and provide relevant solutions. This can significantly improve customer satisfaction and reduce response times. And the next one is code assistance. Developers can use the codex model, a descendant of GPT-3, to generate code snippets, suggest code completions, and even translate natural language instructions into working code. This can be a game changer for increasing productivity in software development. And the next one is document analysis. You can leverage these models to extract key insights from large documents, summarize reports, and even generate insights from structured data like tables and charts. Using the Azure OpenAI service is straightforward. You send a prompt, a piece of text that tells the model what you want, and the model responds with a completion, which is the text it generates based on the prompt. For example, you could send a prompt like write a product description for a new smartwatch, and the model would generate a detailed and creative description for you. You also have the option to customize these models to better fit your specific use cases. This is done through techniques like fine tuning, where you can train the model on your own dataset to optimize its performance for a particular task. This ensures the model understands your unique context and provides more relevant outputs. One of the key advantages of using Azure OpenAI services is the enterprise grade security and compliance that comes with it. All data is handled accordingly to strict security standards, and you have full control over the use and management of these models. This makes it a reliable choice for businesses that need to maintain data privacy and security. To give you an example, consider a global e-commerce company that used Azure OpenAI to automate its customer service. They integrated a chatbot powered by GPT-4, which was able to handle common queries like order status, returns, and product information with high accuracy. This not only reduced the load on their customer support team, but also provided faster and more efficient service to the customers. In summary, Azure OpenAI Services opens up a world of possibilities for integrating advanced AI capabilities. Okay, these powerful language models can help you achieve your goals more efficiently. Whether you are looking to automate tasks, enhance customer integrations, or generate creative content, these powerful language models can help you achieve your goals more effectively. Now, let's move on to see why AI is such a hot topic today and how rapid the speed of technological adoption in driving the changes. We will explore in this next slide. So, why is everyone talking about AI today? What's driving the sudden surge of interest and adoption across industries? Wait a minute. Yeah, let me go to the show this graph. Yeah. So, if we look back over the past few decades, we have seen several technologies waves that have transformed the way we live and work. The internet, smartphones, and social media are just few examples. Each of these innovations brought significant changes, but they also took time to gain widespread adoption. However, AI is different. The speed at which AI is being adopted is unprecedented. Technologies like cloud computing and the availability of large datasets have accelerated the development and deployment of AI solutions. What used to take years to achieve is now happening in months or even weeks. Look A graph at this Look at this graph. It compares the adoption rates of various technologies over the years. You can see how AI is being embraced much faster than earlier technologies like personal computers or mobile phones. This rapid adoption is fueled by the immense potential of AI to revolutionize everything from customer service and healthcare to finance and manufacturing. So what's make AI adoption so rapid? There are few key factors. With platforms like Azure AI, businesses can now access powerful AI capabilities without needing extensive expertise or huge investment in infrastructure. The rapid adoption of AI is not just a technological phenomenon, it's also a social one. AI is transforming industries by automating processes, enhancing decision making, and creating new opportunities. And yeah, we are living in a time where technological advancements, particularly in AI, are happening at a breakneck pace. This rapid adoption is driven by the unique capabilities of AI to solve complex problems and create value in ways we couldn't have imagined just few years ago. With that context, let's look at how Microsoft has been at the forefront of this AI revolution. The next slide covers the significant milestones in Microsoft AI journey and how it has contributed the current landscape. Let's take a moment to look at Microsoft journey in AI space and see how they have been contributing to this rapid transformation we have been discussing. Over the past few years, Microsoft has made significant strides in AI development and deployment. Here are some key milestones. In June 2022, GitHub Copilot became generally available, introducing an AI powered paid programmer that helps developers write code faster and more efficiently. This was a game changer for the developer community. In October 2022, Microsoft launched Microsoft Designer, a tool that leverages AI to help content creators generate high quality graphics and illustrations effortlessly. In Jan 2023, Microsoft extended its partnership with OpenAI and made the Azure OpenAI service generally available. This allowed business to access advanced language models like GPT-3 and GPT-4, opening up new possibilities for AI applications. February 2023. The release of new Microsoft Bing and Edge powered by GPT-4 marked a significant upgrade, integrating generative AI into everyday search and browsing experiences. In March 2023, Microsoft introduced Microsoft 365 Copilot, integrating AI capabilities into its productive suite. This enables users to automate tasks with drafting emails, summarizing documents, and even generating meeting notes. These milestones reflect Microsoft's commitment to making AI accessible and useful across different domains, from software development and content creation to everyday productivity tools. By integrating AI into popular products like Microsoft 365 and Bing, they are bringing the power of AI to millions of users globally. And this is just the beginning. We can expect even more innovative AI solutions from Microsoft in the coming years as they continue to explore new ways to integrate AI into their products and services. Now let's take a step back and explore the history of AI itself. It has evolved over decades. It has evolved over decades to become the transformative technology we see today. To appreciate where we are in the AI today, it's helpful to look back at its origins and understand how this technology has evolved over time. AI research began as early as the 1950s and 60s with some of the first experiments in mission intelligence. One notable project was ELISA in 1966, a typewritten chatbot that simulated a conversation with a therapist. While limited in its capabilities, it laid the groundwork for what we now call natural language processing. Fast forward to 1980s and 90s, AI research experienced a resurgence with the introduction of new statistical models and the increasing availability of computing power. This era saw the development of basic machine learning algorithms and early neural networks. But progress was still slow due to limitations in data and technology. The real breakthrough came in the 2010s with the advent of deep learning and the widespread availability of data and powerful GPUs. We saw the emergence of modern virtual assistants like Siri, Cortana, and Google Assistant, which could understand and respond to voice commands with reasonable accuracy. Today, we are in the age of generative AI, driven by transformer models like GPT-3 and GPT-4. These models are capable of not just understanding language but generating it, creating everything from human like text to code and even art. This marks a significant leap forward, enabling more sophisticated AI applications across various domains. In just a few decades, AI has evolved from simple rule based systems to complex models capable of tasks that were once through impossible. This rapid evolution is what makes the current AI landscape so exciting and full of potential. Now that we have covered the history of AI, let's take a closer look at how these advanced language models like GPT-4, like GPT actually work and what makes them powerful, so powerful. We'll explore this in the next slide. To understand the recent breakthroughs in AI, it's essential to grasp the concept of language models and how they work. Language models are a type of AI designed to understand and generate human language. They are core technology behind applications like chatbots, language translation, and even text generation. So, at the heart of these language models are neural networks, which are mathematical systems inspired by the way the human brain processes information. These networks are made up of layers of nodes or neurons. They are connected to each other. Each connection has a weight, which represents the strength of relationship between the nodes. When a language model processes a sentence, it breaks the text down into smaller pieces called tokens. For example, the sentence, he had tea and she drank iced coffee, would be split into tokens like he, had, tea, and so on. The model that converts these tokens into numbers and uses the network to identify patterns and relationships between them. The model is trained on massive amounts of text data, learning to predict the next word in a sentence based on the words that came before it. Through this process, the model blends grammar, context, and even subtle nuances like tone and style. This is why modern language models can generate text that feels coherent and contextually appropriate. What makes these models so powerful is their ability to handle complexity. Traditional learning models struggle with understanding context, especially in long sentences or paragraphs. But deep neural networks, especially with many layers, can capture these nuisance, making them ideal for tasks like summarizing articles, answering questions, or even writing essays. In essence, long-range models powered by neural networks have transformed how we interact with machines. They enable computers to understand and generate long ways in the way that feels natural to us, paving the way for more advanced AI applications. So now that we have the basic understanding of long ways models, let's delve into one of the most groundbreaking innovation in this field, the transformer architecture, which is the foundation of powerful models like GPT-3 and GPT-4. We will explore we'll explore this how this architecture works and why it has revolutionized natural language processing in the next slide. So now we have the basic understanding of language models and neural networks. Let's take a closer look at how these neural networks actually process and understand a sentence. This will help us approach the complexity and sophistication behind models like GPT-4. When a neural network reads a sentence, the first step is called tokenization. The model breaks down the sentence into smaller units called tokens. For example, if we take the sentence if we take this sentence on the slide, he had tea and she drank iced coffee. The model might split this into tokens like he had tea and so on. These tokens can be words, parts of words, or even individual characters, depending on the language and model. Once we have these tokens, the next step is to convert them into numbers. Because neural because neural networks operate on numerical data, each token is assigned a unique number, which we call an embedding. The embedding captures some properties of the word, such as its meaning and usage context. So, coffee might be represented by a certain number and tea by another. But because they are related, their embeddings will be somewhat similar. To process this information, the model standardizes the length of these embeddings into fixed size vectors. In simple terms, think of it as stretching. Yeah. Think of it as stretching or shrinking each sentence into a uniform size so the model can handle sentences of different lengths consistently. If the sentence is too short, we add padding. If it's too long, we truncate or split it. So, yeah, models like GPT-3 and GPT-4 are built on this wait a minute, on this transformer architecture. By leveraging the attention mechanism, they can generate coherent and contextually accurate responses, even for long and complex prompts. So now that we have seen what makes transformers so powerful, let's move on to explore the different generations of these language models from GPT-1 all the way to GPT-4 and how they are evolved over time. We will cover this in the next slide. So you can observe that uh, these are, as I said, the context matters and vice versa of it. So what's new in Transformers model? Mary already had coffee that morning, so she didn't accept a cup of iced coffee his colleagues offered her. This is a sentence. So why didn't Mary accept the coffee? This is a question. So the question is itself in this the answer for the question is itself in the paragraph. Why did Mary accept the coffee? Because Mary already had the coffee that morning. That's why she didn't accept the coffee, accept the cup of iced coffee his colleague offered her. So recurrent NNs neural networks are based on windows of words and encoders parameters that can be as smart as the sequence it sees. The bigger the window size, the more the cost of training. The higher the complexity and probability of errors. So transform, yeah, attention. Let's deep networks learn meaning without proximity. Attention lets deep networks learn meaning without proximity. Mary already had coffee that morning, so she didn't accept a cup of iced coffee his colleague offered her. This is the sentence we given. The transformer model is able to look at different combinations at the same time, leading to powerful encoders, smarter and time or energy efficient. While traditional neural networks and even recurrent neural networks made significant progress in natural language processing, they had limitations, especially when it came to understanding long range dependencies in text. For example, they struggled to keep track of context across lengthy paragraphs or even long sentences. Uh, this is where the transformer model comes in, introduced in a groundbreaking research paper by Google in 2017. Transformers have revolutionized the field of natural language processing. They addresses the limitations of previous models by introducing the mechanism called attention, which allows the model to focus on different parts of a sentence with varying degrees of importance. Think of attention as the model's ability to selectively focus on specific words when making predictions. For instance, consider the sentence, the cat, which, which was sitting on the mat, looked at the dog. To understand what look refers to, the model needs to pay more attention to the cat than the words in between. The attention mechanism enables the model to do exactly this by assigning more weight to relevant words and less to irrelevant ones. Like RNNs, which process information sequentially. Transformers look at all the words in a sentence simultaneously. This parallel processing capability allows them to capture relations between words more effectively and efficiently, regardless of their position in a text. As a result, transformers are not only faster but also better at understanding complex language structures. Models like GPT-3 and GPT-4 are built on this transformer architecture. By leveraging the attention mechanism, they can generate cohort and contextually accurate responses even for long and complex prompts. This is why they excel at tasks like language translation, summarization, and content generation. In short, the introduction of this transformer model and its attention mechanism has been a game changer for AI. Let's take key innovation that has enabled the creation of powerful language models capable of understanding and generating human like text with unprecedented accuracy and fluency. Now that we have seen what make transformers so powerful, let's move on to explore the different generations of these models, like models from GPT-1 to all the way to GPT-4, and how they experience it. Yeah, and how they have evolved over time. We will cover this in the next slide. So you can observe the graph here. So GPT 4, 3 and 4 was evolved with the time, as you see in the graph. So the breakthrough in recent AI development in transformer models, which introduced the concept of attention. Unlike previous models that processes words sequentially, transformers look at multiple words at once. This allows them to understand context more efficiently and improve language understanding. GPT-3 and GPT-4 are built on this architecture, enabling them to produce high quality text responses quickly and accurately. So to extract the mailing address from this email, it was mail. We have to extract mailing address. So the prompt we have given is the prompt is text input that provides some context to the engine on what is expecting. We have to give it as a prompt. So what is the key terms? Extract the mailing address from this mail, and output that the model generates based on the prompt is called completion, and it was extracted the address. It was an address given in the mail, and partial or full words processed and produced by the GPT models is called a token. So OpenAI plus Microsoft. Azure OpenAI services offers several use cases, such as content creation, language translation, and customer service automation. It allows businesses to quickly generate human like text and understand user queries, making it ideal for building chatbots or summarizing information. For example, a company could use GPT-4 to understand customer support questions or write product descriptions. Sorry for the interruption, guys. So let's continue. So here we can see that the combination of collaboration of my OpenAI and Microsoft. OpenAI ensure that artificial general intelligence benefits humanity, and Microsoft empower every person and organization on the planet to achieve more. So GPT, coming to GPT 3.5 and GPT 4, it will basically works on the prompt and will give text as an answer. And coming to the chat GPT, it will be the conversation between the human and AI. So, and if we see the codex, it will give the code according to the prompt, and in DALE E2, it will give images accordingly to our prompt. So, prompt. What is prompt? So, write a tagline for an ice cream shop. That was a prompt, and the response is, "We serve up smiles with each scope." And there are few things about you. You try to troubleshoot this issue, and like we can see the response here, and these were the technologies used. And Microsoft Cloud actually deployed within your Azure subscription, secured by you, accessed only by you, and tied to your datasets and applications. And enterprise grade security with role based access control and authentication, and secure networking through private endpoints and VNets. A Cloud goes into the data governance, analytics, and operational databases. And it was a Microsoft Intelligent Data Platform, and it all comes under the AI. So top use cases customers are innovating with. So coming to the summarization, long product reviews, articles, long form reports, and efficient bot to human handoff with summary and insights from unstructured data. Coming to the conversational AI, customer service bots, enterprise question and answers, end-to-end contacts enter solution. In writing assistant, it will create ideation and design, and it will give content writing assistant. Coming to the knowledge mining, you can see domain specific research, social media trend analysis, surface cross functional insights in enterprises, and faster software develop for the fast software of development of software, code generation and auto completion, code documentation, refactoring are the resources we can refer to. And Azure AI is not as Azure OpenAI services. Azure AI is different. Azure OpenAI services are different. So in Azure AI, you can see the applications such as Microsoft 365, Microsoft Dynamics 365 partner solutions, and application platform like as it is also called as AI Builder. It comes under Power BI, Power Apps, Power Automate, and Power Virtual Agents. These are all technologies comes under business users. So in and scenario based services, like it is also called as applied AI services, like bot service, cognitive search from form recognizer, video indexer, metrics advisor, and immersive reader. And coming to the customizable AI models, it is also called as cognitive services. It's also comes under vision, speech, language decision, and Azure Open AI services. And coming to the machine learning platform, Azure machine learning. So these are all comes under developers and data scientists. These are the technologies used by them. So it was the one of the part of Azure OpenAI service. So Azure OpenAI service is a subset of Azure AI. So Azure OpenAI considerations. The first one is I need a general purpose model that can handle multiple tasks. Example: translation plus entity recognition plus sentiment analysis. And we need to generate human-like content while preserving data privacy and security. Example: abstraction summarization, content writing, and paraphrasing code. We need rapid prototyping and quick time to market for many use cases. We could use a model with little or no training, and we want to explore solutions, use cases that have been described previously. These are all Azure OpenAI services. So, yeah, in Azure OpenAI services, vision, speech, language as decision, these are all comes under along with them. It was all together is called Azure AI Cognitive Services. So you can see the website and overview of the platform here. So Azure OpenAI service pricing, and you can see the platform here. So you can also do a demo. You can able to chat with your data using ChatGPT and Azure service. Actually, it is a demo, and we have to, if we want actual one, we have to buy it. So we can able to chat with your own data using ChatGPT and Azure service. So there is an app, Azure app UX. To that app server or switcher, from that it will connect it to Azure OpenAI service, and it was further go with Azure Cognitive Services, and it will read the documents that we have been provided. Azure Form Recognizer will read the document, PDF pipeline, OCR pipeline. So using AI responsibly, social implications. So do not humanize AI. Generative AI is not intelligent, deterministic, grounded. And generative AI can't understand language or maths, understand manners or emotions. No facts that are not in its training data set. Cannot known facts that are not in training data sets. Always ensure to use AI output responsibly. And you can able to see the Trovo image. It was the image created by DALI E2. It was a crying robot. So how to mitigate hallucinations? So effective prompt engineering is the one of the best solution, and we have to provide validated data sources, and we have to ask for citations, and we have to tweak parameters like temperature or maximum length. We have to mention that, and we have to filter the content that we are giving. So Azure OpenAI Service Learning Guide. So we have to start here. We have to create an Azure subscription, and it will apply for access to the Azure OpenAI service. You can see the link here, and after that, yeah, there is a basic type in which we have to understand what is Azure AI, introduction to Azure OpenAI service, training module, and we have to explore. We will explore key responsible AI guidelines and principles. Coming to the intermediate part, we know the how your data is processed, used, and stored in Azure OpenAI, like data, privacy, and security. And we have to review the enterprise data with ChatGPT, TechBlock, and work through the accompanying GitHub repository. Coming to the advanced part, we can see the examples in the OpenAI cookbook, and we can get support and help. So, wait a minute, guys. So AI is powerful, but it comes with responsibilities. It's essential to use AI outputs responsibly and avoid humanizing AI. All models like GPT-4 don't understand emotions, facts outside their training, or concepts like morality. We must be cautious about AI hallucinations where models generate misleading or incorrect information. Techniques like effective prompt engineering and content filtering can help mitigate these issues. So, to wrap up, Azure AI offers a robust set of tools and services that empower businesses to implement AI solutions quickly and effectively. Whether you are working with cognitive services or Azure OpenAI or building custom models with Azure machine learning, the possibilities are vast. As AI continues to evolve, So will its applications come across industry. As AI continues to evolve, so will its applications across industries. Thank you for your time today, and I hope this session has provided a solid foundation for understanding Azure AI. And once again, thank you so much for joining, and thank you for the learning. Wishing you a very happy learning. Have a nice day. Thank you so much. Bye bye.